Should we start now?
Sure, go ahead.
Okay. So nice. So here. Yeah. All right. I'll just use the normal mode like this. So the motivation is that well, I believe we all know what's going on, but I'll just go over this. So electrical motor generate noise mostly from the back EMF. And then the spikes in ground will alter the ground potential, that the ground is no longer 0 volt, and then 12-volt supply becomes maybe negative 1,000 volt, and that would damage everything. And then small noise also affects analog signal. So there are two examples. One is in our lab, there's another project, and there was a Novatel GPS on it that was damaged by the ground noise. And second is a project that's going on with my friend, that he has this electrical motor vehicle, and whenever he accelerates, and his computer restarts. So we kind of analyze it, and we think it's the ground noise problem. So the plan is to use isolations. So the motor and the motor controller has the same ground as the battery and chassis, because the motor is where the noise comes from, and the control circuit has a floating ground. And then we use isolated DC-DC converters to isolate the ground noise, and then we use optocouplers for communication isolation. On the right top, this is just a example of a magnetically coupled isolator, but there are also other kinds of isolators. So in this example, the DC voltage is first converted to AC voltage, and then AC voltage can be passed through a transformer. After the transformer, everything will be converted back to AC voltage. And because the transformer doesn't have DC components, and all the noise will be contained on the left side instead of transferred to the right side. And then the optocoupler is used for communication, because usually you need common ground for communication. If you have a digital signal, the receiver end needs to know what the reference ground is in order to read that signal. So in that case, you need a something that doesn't connect electrically. So in this case, a optocoupler communicates with light, or photon. Basically just a LED transmitter and receiver. So here's a solution. Here's a really simple example. On the left side, we have the battery and the battery ground, or a chassis ground. It goes through a DC-DC isolated DC-DC converter. In our case, we use a 9 to 18 volt to 12 volt converter, which is 100 watt. That one costs like $50, mostly 60. There are also expensive ones, but the one we use are really cheap and it works really well. On the right side, the isolated signal now powers the PC and the microcontroller, and this blue wire represents communication between the PC and microcontroller. Everything on the right side has the same ground level, so there's no need for isolation between the PC and the microcontroller. And going down here, we have the motor and the motor controller. However, the motor controller needs to take commands from the microcontroller, and we use this FOD AT12A. This chip is a bidirectional optocoupler, and it works perfectly with digital signals. Especially it is bidirectional. That means if we use serial communication, the transmit and receive signal can be isolated using the same chip. And then on the right side, since everything has a floating ground, you can run your sensors without any problem, without any noise in your ground lines. And yeah, that's the really basic setup. Well, that's the idea behind the electrical isolation. And there are also some cautions need to be paid attention to. Once the floating ground should not be connected to the battery or the chassis from at any place. This is a really common mistake because when you design your circuit-wise, everything is perfect, everything is perfectly isolated. But when you put all your sensors, your circuit on the robot, you may connect some sensor shell to your robot by mistake, and then all the ground are connected together again. So in our case, we have this control box that's on top. The bottom is a frame, and we use this shock absorber. It's a rubber shock absorber in between them. First, the shock absorber works. It absorb any little vibration, and second, it also provides electrical isolation. And there are some other considerations that we didn't use on our robot, but I have been working on this during the summer, which is the analog signal isolation. And I found this circuit online. There is a kind of amplifier, which is a isolated amplifier. And here is a example circuit on how to isolate analog signal. Also in here, the ground on the uh, right of this dashed line is different from the ground on the right. And this is a differential ADC amplifier, but it can be converted to single-ended. There are also other solutions. For brush motor, you can place a capacitor between terminals, and for the brushless motor, you can use inductor in series with motor winding. And that's actually all I have. It's a simple concept, and I don't really know like what else I should explain. And I'm looking for questions actually. I hope I explained it well, but I um,
Yes.
can answer questions.
On this slide here, I was wondering, how do you isolate the PWM signal? Would you use this same chip, and
Yep.
can handle the frequency?
Yep. This particular chip can handle high frequency. I didn't check the delay, but you can just Google this FOD 8012A, and on the data sheet there is the latency is written on the data sheet, and it handles PMM signal really well. We used 20 kilohertz per PMM. It works really well.
Okay. Excellent. I didn't know that you could put the 3.3 volts on one side and then have 5 volts on the other side.
Right. That's something I forgot to mention. This chip also double as a logic shifter. So if you're using a 3.3 volt based microcontroller and your motor controller use 5 volt logic, this is the way to scale the PWM signal.
So after you put all that stuff in there, did you get rid of all of your problems, or is there still a few nagging problems left over?
For me, for the robot that we use for iCloud, we didn't encounter any ground noise problem at all. Like once the low-level controller was built and installed on the car, there were no problem at all. There were no like restarting, and there were no well, we didn't really measure the ground noise, but like there were no problem with the GPS with the computer that happened on other robots. Because we know that there are problems with ground noise, so we designed the circuit at the beginning.
Were there certain things in there that were more problem than others? Like if you had several motors, is there a certain kind of motor that's a problem, or did it just depend on what you had?
Well, all kinds of motor generates noise, so It doesn't really matter what kind of motor you have.
You mentioned you used an inductor in between on the in series on your motor. I was wondering which one you used there.
I can double check with the presentation I gave last time.
Was it?
Well, I'll find it. I'll post it here. I think it's a 4.7 millifarad or 4.7 farad. I forgot, but I have the circuit. I can look at it.
Do you have these slides posted online somewhere?
This one?
Oh, the series of slides you were showing here, is that posted on your website somewhere?
No, but I'll post it in the channel.
Okay.
Oh, if that's it, that's all I have for ground noise handling.
And
Until the congregation.
that, exactly.
In anybody's experience, would a steering valve, like a Danfoss valve, would that solenoid, would that be a source of noise possibly too? And I know it's not a rotating machine, but I'm thinking they might be fairly quiet.
Well, you have to be careful anywhere if you have, say, a relay or any kind of solenoid, you're just turning on and off. That if you're putting a DC to turn it on, and then when you turn it off, you just as it turns off, it creates an inductive spike. So you want to put a diode across all your coils when you do that. As far as like say a Danfoss steering valve, if you're putting a PWM into it, I guess I don't know. I guess I don't know what that would do.
Okay.
It may create less noise because it's a motor as it turns. It's got the brushes that it's turning the commutating circuit on and off as it turns. Whereas if you're doing a solenoid, it's really you've got probably a PWM circuit. So you've got like a driver transistor that's turning the thing on and off, and your driver, depending on how you build it, may have built-in diodes too to get rid of some of that noise.
That chip, I just looked it up on DigiKey, and I mean, obviously it's not very expensive. It was only $5, but it looks like it was a surface mount chip. Did you create your own board to mount that on, or did you buy some sort of development board that had it packaged? Howard?
Oh yes, there are. We used from Amazon. There are like surface mount 2 through hole converters, and those are the one we used. If you want to use surface mount on our prototype PCB.
So you effectively made your own board and mounted it, the surface mount.
Yeah, so we use here, hold on. Let me share my screen.
SparkFun has a little adapter board you can get that's probably the same type of thing that they used. You just solder the chip onto that, and then you can plug it into your through hole parts.
Something like this. And we use the
Matt, have you noticed any noise in communicating with your motor? Or is it noise that it's causing for other devices like your angle sensor?
The biggest noise I found on the system came from the super servo. But the electric power steering also. So what Howard was saying about isolating those grounds and isolating the different voltages, that's helpful. And that chip also will be very helpful because the TC is 3.3, and then the Citron PWM is the 5-volt side. So putting that chip in there in between the microcontroller and the motor controllers, that's super smart.
Howard, you were blazing through those screens where you saw that you were sharing, I think, a little board that made it easy to put a surface mount on. I didn't actually. I saw it whiz by, but I didn't actually. What would you Google if you were looking for that?
I'm sorry, I didn't click at it.
What board did you get to help you mount that surface mount?
Oh, yes. I just Googled surface mount to through-hole adapter. And there's like a little PCB that allows you to solder your surface mount. And then the other side is the through-hole you can put it on your maybe breadboard or like a prototype PCB.
Found it, thank you.
Yeah, no problem. I just uploaded the presentation.
That's great. Any more questions for Howard or? Howard's team took first place in the autonomous soil sampling competition. They had a robotic arm and everything on their robot. They drove autonomously. They have obstacle detection on their robot. There's very nice setup. A lot of work.
Thank you.
How can we ask a question about their robot? I mean, what did it weigh, and how big was the steering motor in amps that it drew when you were operating?
We just use the stock power electrical power steering motor, and we don't have a spec on that motor, but we have the stall current was like 38 amp, and well, because we don't want to damage it, so we limit the output current to 20 amp, and also that's also the current limit of our motor controller. So with 20 amp, it cannot steer when it's stand still on concrete. But when it's driving, when it's moving, it steers really easy. Because because the resistance of the steering wheel. And also, we use a Robotech motor controller, and when it limit the output current, it will when output current reach the maximum, it will stop for a little while, and then and then resupply current to the motor again. So what you actually see on the motor when it is like it's trying really hard to steer, but it cannot, and it's like jiggling there when it's staying still. But when it runs in the field, there's no problem.
And then I'm assuming it was Ackerman steer?
Yes, right. We use our robot is actually a Yamaha ATV.
And then for angle sensing, what did you use for angle sensing?
We just use the AMU.
Oh, you just used sort of compass heading for direction of travel.
Mm-hmm. We use the Novotel AMU. We use it handles sensor fusion inside the box. So from the data we get out of the box are already filtered, already fused, and it's really accurate. Oh, you mean the position control of the steering wheel?
Yes, you were running your 20 amp motor, and then
Okay.
go left or right.
Okay. Okay. We use a absolute encoder from US Digital. That one costs $80, and the output is PWM signal. I'll post a link here.
Well, if you won the competition, you must be doing a lot of things right. So good for you.
Thanks. I just posted a link in the chat, and that's the absolute encoder we used. We attached a gear on the steering wheel, and the other side of the gear connects to this encoder. So once the steering wheel rotates, we know what the steering angle is at, and then we use that for feedback for position control.
Which Yamaha vehicle did you automate?
The Wolverine. It was sponsored to us, I think, during the second year of ACBOT.
Matt, you should run out and buy one of those.
I wish actually I want to buy one when I get the money and get a space when I get a house. We actually drove that into the field on a technical trail. It was a lot of fun. It was like the year before when we do the watermelon harvester, and after the competition, there was a guy who was a friend of the garage family, and he took us to the back of the farm. There's a technical trail, and it was really amazing. And then I fall in love with this. Well, the guy called machines, and I always want to drive it again in technical trail, but apparently our professor doesn't like it.
Howard, I did have a question. Have you ever experienced any ignition noise from any of the motors that you've had on vehicles?
Yes, I don't think it's ignition noise, but it's like power hungry. So once we turn the ignition on, the battery voltage drop a lot. Like the ignition motor takes all the current, and then that causes all our electronics to lose power. We did have that problem, and our solution is to turn on the ignition before we turn on the computers. And also we have two switches that we installed on the dashboard that turns on and off the low level controller and the high level controller individually. So so we can turn on the ignition before we turn on the electronics.
You do that manually, like a startup sequence?
Yes. Otherwise, if we have all the electronics running, and when we turn the ignition on, everything will just restart and reset. So the computer will restart. But we think that may cause some problem to the computer, so we try to prevent that. However, if we have a alternative battery or a auxiliary battery inside of the computer box, that may solve the problem.
That's great.
Do you have a link to YouTube of your machine running, your bot running?
Me?
Yeah, you or your team. Did you post anything on YouTube as far as your machine when it was in the competition?
Uh, I don't think I've posted any videos,
Okay.
but I can. I mean, I think I have some clips. I didn't check. I can post them later.
Well, some of the people, Matt, you were probably there.
Yeah, Soen and I were there.
Yeah. Okay. I was hoping to represent this year, but didn't work out. To be next year.
Well, we're looking for an organizer for the AgBot Challenge, so a community organizer. I thought it would be fun if we get a little bit better planning. We can let people know when it is and all the event details, and then maybe we can go out there together. Be fun.
I was going to say too, as long as I got the mic, if you're going to go after sponsorship, you probably need a little bigger logo. It should be at least as big as your head as a rule of thumb, I think. No, Howard, that's great work. Congratulations on your win.
Thank you.
What's up for next year?
Well, our professor will not have another team for next year. However, I was thinking about joining AgWorld on our own. I already found under 3 guys, and there are 4 of us. We are planning to have a startup company, and we will be targeting autonomous agriculture. But everything is just a thought. We don't have any plan yet. We are just talking about it. But I think at least the 4 of us will go to the AgWorld competition next year, no matter if we are doing the company or not. Well, like right now, we don't have any plan. We just have this thought because our professor, he has a lot of project to advise, and since we win like twice, and he was like, "No, Howard, you need to focus on your master research instead of doing the doing the competition." I was like, "Okay."
Howard, do you know when they release what the competition's going to be, or does that come about six more months or so?
I don't know. I think last time I talked to Rachel, she was like, "We're gonna do the same thing again. Like, we're gonna do the winner feed and the soil sampler again." But I don't know more information on that.
Okay.
And so, Matt, for path planning, I mean, how is Virginia Tech's path planning different than what you've been testing?
Well, Howard can speak about what they're using. They're using MoveBase. He covered that in the last video. What I did at the AgBot Challenge, we did the pre-planned path. So we had a pre-planned path, and then just used Pure Pursuit to follow that path. So I went out to the crop rows where the corn was planted, and then just did a point at the start of the row, into the row, and then next row over, start of the row, into the row, and then used Dubin's path to make the path between the 4 points, and then just drove that path.
Did I hear somebody mention earlier noise from the super servos? Or are they pretty robust or clean?
was the question on the noise on the super servos, or?
Yeah, I thought I heard a mention of some noise coming back from the super servo. And then the other question. Oh, go ahead.
I posted in the lawn tractor channel. You can see some of the graphs of the power spikes with the motor turned on. Now, I need to improve the circuit. I did isolate the different voltages on the system, but I haven't put the insulators like Howard showed us tonight.
Okay. And then I forget who posted the link to the super servo hacking, if it was you, Matt, or maybe Jeff. But Jeff did. Yeah, it was, if I recall, the repeatability was 10 degrees. Does that sound right, or am I reading that wrong or remembering it wrong?
That's kind of what I've been seeing on the thing, but he gives some theories on how to improve it, and Matt is just kind of bypassing the whole thing, where he takes the feedback from his speed and then feeds it back through a loop and controls the servo to essentially just get rid of the extra slop that's there.
Okay, so he was using it on steering, or that was his hydro lever? It was the hydro lever, I guess, in his case.
Yeah.
Okay.
The hydraulic or hydrostatic transmission.
So on mine, I'm going to try to use it for the steering, and I've got to actually try driving it around, see how that's going to act. Another option is you can go inside the servo, and it's got one of those magnetic shaft encoders built into it, like that one that Al put on his steering. It's got that built right into the thing, and it's using the voltage mode. So the guy in that article says just solder a wire on here, and you can get the voltage out. So you can feed that into an A to D and get the actual position. So then again, like Matt's doing, where you can take that, you tell it to go to a certain position. If it's not there, you keep increasing you keep nudging it over until it gets exactly where you want it to be. So that's one way around that.
Okay.
Or you could just take that position out and run it through your own microcontroller and then drive the thing directly. You know, it's got a mode you can put it in. You put it in continuous rotation mode, where it basically just becomes a motor. So you could do that. Just use that essentially as your power amplifier, driving the servo back and forth, and then run it through your own microcontroller to do that.
Okay.
Jeff, your robot is looking very nice. We're going to have to get another presentation from you to see all the improvements you've done. Very professional.
And one of these days, I should sit down and make a YouTube movie and go through and figure how to do my video editing, so I can do a walkthrough and then go back and put all the pieces together and slip in some just static slides and whatever it needs to show it off. So.
Have you added the ground effect lightings yet?
No, haven't done any of that stuff yet.
Looks great. Jim's been doing some testing on the torque. For the electric power steering? What did you learn from your testing?
I learned that having some sort of current control would definitely be a benefit. And Howard may have mentioned it, that some drivers have current control built into them. How cost effective are they? Do we need to look at a standalone current sensor with a nano or something like that, or just upgrade to a different driver that has a current sensor in it or a current limiter?
The one we use is a Robotech motor controller that has built-in current sensor and limiter, but that one costs a lot. I think it costs more than $200, and maybe more than $400. But I also found.
What is the current limit on that driver board? How big a motor?
You can. It is single channel 40 amp, and but we did in the setting to limit to 20 amp.
The other thing I think I want to go ahead and test is, if a person did need more power out of these motors, they're probably fairly robust. I would speculate right now, without actually testing it, that a person might even be able to run it on 24 volts if your demand was momentary and not continuous.
I haven't run any tests, but I have snapped. I've got the motor connected to a U joint, and then the U joint is connected to the steering shaft with a roll pin, and I have snapped that roll pin with the motor once. And I have a 15 amp fuse on the line. And in the controller, on the PWM for the motor controller, you can tell it how much power you want it to drive with. And so it's like 0 to 255, and I'm at 55, so I'm about 1/5 the power from in the controller side. Do you know how much power you need?
Every application is going to be different.
Right.
It depends on how large of a tractor or whatever we wind up. We're just at this whole learning phase of what its capabilities are, but like everything else in life, you always seem to find applications that tax whatever it is you're working on. I think what a person just needs to be more cautious about is when any sort of a steering system, if you mechanically bump it up against a stop and it still has more motion within the servo or within the electric motor, it's got a sense that it came against a stop, and your software then I think needs to recognize it and cut it back very quickly.
Yep. Yeah, that's a good point. So maybe a fail safe around that if it hits the lock, or is that where that current limiting would help? If the current starts to shoot up, then you can limit how much it's pulling.
Correct. The other thought that goes through my mind is if a person didn't have current sensor, you could probably do it through software. If it was attempting to move to a position and within half a second it didn't see any movement, it should go into a limited current output instead of keep trying. At some point you've got to kind of write that into it, I believe. Lots of those things to be bugged out yet. That's kind of where I wanted to go with the whole electric power steering as a servo replacement, is try and get a lot of this stuff figured out and written up and something that other people could download a library and have it available.
Yep. As a fail-safe, that's a good idea about checking your wheel encoder, and if you're not getting movement within what you would expect, to shut it down or limit the current.
Yeah, at least limit it. Not have it give up completely, but keep it from getting into that 45 or 50 amp range that's going to blow something up.
Yep. Like Howard was saying, if the vehicle isn't moving and you go to turn the wheels, like mine won't turn. They'll try to turn, but they won't turn. But once you start moving, then the wheels will turn. So it could be different scenarios.
And that's the exact reason to have it, where if it's being commanded to move and it doesn't move, at least have the software where it's in a safe zone, where it's not overtaxing anything. Once it does start moving, though, it's nice to have a system that's responsive, that can go back to a higher level if you do command it to turn and want it to turn rapidly.
I just posted a link in the chat, and actually the second link. There's a current sensor, like two of them cost like $11, and that's a 20 amp range current sensor. I have someone in my lab works with that sensor. It works really well. It output analog signal. And there are also higher current range versions.
Yeah, I've seen that ACS 712 chip-based sensor on a lot of applications. I've ordered a couple just to, they're inexpensive, just to have them on hand and see what they're like.
That's excellent. Arjun or Alan, you want to talk about your progress on the AWS?
Yes, thanks to Bazad's help, Arjun and I spent a lot of time working on bugs, really small bugs, and then Bazad would go back and fix it. And something must have changed. He had some problems with the NVIDIA drivers that were installed, and so he made some changes, and we have it working now. So we have the lawn tractor, we can drive it around on the screen and that type of thing. So it's using a GPU instance on Amazon, on AWS. And I think it's probably best if you get the machine image from Bazad, but I think for a few people, he'd probably let us share it with them as well. So, but now we have a base image with Ross that we can experiment with and start expanding and learning. So it just works when you start it up. So that's kind of nice.
Excellent. Any other projects, questions, or? Go ahead.
So I wanted to ask both Matt and Jim on that controller from the power steering. Have you taken off and looked at the back of that board to see what's on the back of that, the controller board? I haven't taken mine apart yet. It's still stuck in the box, and it looked like if I pull it off, it's going to rip the transistors off or something. So I didn't try to get it apart. But just looking at it from the side, I thought it looked like there was more big surface mount parts mounted on the back of the board. And I'm thinking that's an awful lot of parts to run a power steering. So I was just curious what the back of it looks like.
I can take a photograph and send it to you. It looks like the external tracks are much heavier, so they must be running current through those. But I'm sure you won't be able to see it, but there's 4 different layers inside the board. So as far as trying to reverse engineer it, that's where I gave up. And you were absolutely correct. The MOSFETs are attached to the board. You can kind of bend that board out of there a little bit, but I'm not sure how they assembled it, but those MOSFETs are anchored to the aluminum casting. So I'm guessing they must solder the MOSFETs to the board at a different angle and then screw the MOSFETs to the heat sink on the casting and then bend the board down in to mount it is my guess, because as you have obviously looked at, when you first look at it, it's like, how do I get this thing apart? They are some nice large MOSFETs, though. They're big.
Yeah. So there's separate boards there. That was a board that had a couple relays and an inductor, and then there was a separate board that had the electronics on it.
No, I sawed that mother right in half.
Oh, do you have the other half laying there handy?
Probably. Let me dig around here. I never throw anything away. If you could see my shop, you would relate to that. I can send you photographs of it.
Okay. Oh, what's on the back of that? Okay, what's on the other side? Yeah, there's another big chip on there, and as I say, it seems like a lot of parts just to do a power steering unit, but so I don't know. So I was noticing on the top side there, over by the what looks like the microcontroller, the one that doesn't have those extra tabs on it. It looks like there's either 12 or 22 test points down there. So I was thinking about just powering it up and putting a scope on those and seeing what those different test points are doing and see if there's anything. Yeah, so right to the right-hand side, there's that group of pads and kind of right there.
Yeah.
There's a bunch of pads there, and they're all marked as test points. So I thought just put a scope on and see what they're doing, and number one, see if they're doing anything at all, and then twist the shaft and see if any of them change at that point. Without actually tracing out the board, because since there's a lot more parts on the back, yeah, that would be pretty tough to figure out what's going on.
It's above my pay grade. What most people write about are the frustration, and you probably saw my comment, Jeff. A lot of this CAN bus communication is nobody's hacked it yet. It's, for lack of terms, proprietary. Until somebody discovers how that we can get some of these controllers, the CAN bus is already there, but nobody knows what to tell it or what to listen to. I made a comment on some of these cruise control, the adaptive cruise control have radar on them, but again, they're great units, they're very robust, but nobody can utilize them until we hack what the CAN bus is trying to communicate. Even to get the unit to fire up, it has to receive CAN bus communications.
We've had a couple of different radars. One's from Delphi and one's from Preco. And both of those, when you turn them on, they start spitting out data. And if you sit and look at it hard enough, you can tell, you can start putting your hand in front of them and see what numbers change. And I think on both of them, we ended up, one of the guys here just sat down and played with it and figured out which fields had the values in coming out. But that's not like an adaptive cruise control where it's got all kinds of really fancy features. So if you get some time on your hands to like playing with that stuff, it's kind of like solving puzzles or taking a PC board and reverse engineering circuit off from it. It's the same kind of concept.
I should have gone to more college.
You don't need a lot of college. We just had some guys here visiting from China, and the guy says, he pulls up a business card. Says, "Oh, do you have a business card?" "Well, I don't have business cards." And then he says, "Well, what's your job title?" He says, "Well, I don't know what my job title is. I'm a contract guy." And they told me I can't call myself an engineer because I don't have a fancy degree. So it's just one of those things. It's one of those things, if you like doing it, you're going to do it, no matter what your education is.
The last trade show I went to, I wrote on my name tag, I was the instigator.
Yeah.
I mean, do you think that CAN bus is something worth using? Is that a good signal message to use? Pluses and minuses?
That's what the OEMs all do. All these modules, like the electric power steering is looking for a speed data from some other component within the car. The radar is communicating over the CAN bus to tell everything else what to do. So, and I'm just going by what few articles I've read, but the OEMs have this, they're building robots now. These cars have all these sensors that are interacting, and they've chosen to use the CAN bus, from what I've gathered, to make it all happen and come together. Even like the range sensor on the back of your car, what I've read on those, when it starts up, it needs a signal from the central processor to tell it what position it's in and then what range it's supposed to start up as. There's all this checks and balances built in. One part may wind up being in the center of the bumper. It may wind up being out on the edge of the bumper. And the CPU tells them to start up in different range modes depending where they're at. There's all, again, I'm just regurgitating articles that I've read. I haven't sat down and designed any of it.
You know, my main opinion is I'll use it if I have to. And they keep handing me stuff saying, here, make this work, because it's got a CAN bus, because everything at Danfoss has to be on a CAN bus. So that's why I keep ending up with this stuff. But, you know, if you have to, you can make it work. So
What I'm most impressed with is automotive grade instruments are very put together well to handle all the environments the world dishes out to them, whereas some other instruments may be more lab type that don't have the longevity and the harsh environment that we're hoping to have stuff perform in. So I like, and they're cheap. You know, if you can buy a radar unit salvaged from a wrecked automobile, it's going to be under $100 in most junkyards today because nobody's got a use for it. Of course, if we figure out how to use them, the price is going to go up.
Yeah, I don't think it's unique to auto either. I bought that Invacare Pronto wheelchair, and they use a bus. And there's a guy that there's a couple of links on YouTube or web videos on YouTube how he kind of reverse engineered the message passing, and it's on the CAN bus. It's pushing out a identifier string. And the timing of it, he found, was very, very fussy. You know, he was just basically just trying to get rid of the joystick and use, you know, drive their motor controller, the wheelchair motor controller with his board. But he had to decipher or decode what it was looking for. He was able to do it, but it took significant effort and a lot of scope time. On the ag side, I'm also hoping the right to repair. Maybe some of that stuff will be opened up in the future. I don't know.
Yeah, I'm hoping eventually that stuff, either some engineer leaks it or, like you say, the right to repair laws do get changed.
Yeah.
Manufacturers certainly have the necessity to protect their investment dollars for development, but at some point, right to repair needs to be part of the equation.
Having a CAN bus option would be nice, especially talking to implements or long distances around the robot in a noisy environment. It adds another layer of complexity to learn a new technology and messaging system, but maybe that'll be something to add. That this little blue pill, this STM32, has CAN built into it. Jeff turned us onto this little board. It's a $2 board, but it has a CAN bus on it. So this is a pretty inexpensive device to turn your motor or turn some controller and be able to talk to it over CAN.
But don't forget, you have to add a $3 transceiver, CAN transceiver to that board to get your CAN to work.
Okay. So you have to have an additional part on there?
Yeah.
Okay. Now we're at $5.
The guys at Accutronic Robotics who make the Mara robot arm, they are a big advocates. They are big advocates of the EtherCAT communication protocol. It is similar to CAN, but they say they prefer that. They're focused on doing a lot of real-time stuff, and they work a lot on. More recently, they're working a lot on they're pushing ROS2 on their devices. So. Yeah, I'll try to find the blog they wrote about the EtherCAT devices. I've read about it once or twice, and it looks promising.
So my team used EtherCAT on our robot, and we use this chip made by AT&T, and it can be used on a Arduino. However, Arduino cannot run at real time, so we also have another version is a EtherCAT Pro, and you use SPI communication with the master with your microcontroller, and we use a TI C2000 real-time microcontroller. I'll post a link here. So the first link I'm posting is the shield for Arduino. And the second link is called EasyCAD Pro, which uses SPI communication with any microcontrollers. This piece of hardware can get you started with EtherCAD very easily. And on the high level part, you don't need additional hardware. You just need the Ethernet port or Ethernet adapter.
Why did you choose to go with EtherCAT over just using like the network?
Last year we used network, we used UDP, and we experienced some communication delay and some package drop. And EtherCAT solved that problem. And also, putting an EtherCAT shield or a Ethernet shield, I'll introduce additional hardware. So we're like, why don't we just use EtherCAT? And also, I'm working in the lab on EtherCAT hardware. So it's like, so I made that decision.
That's excellent. I heard the EtherCAT has a very large throughput. The data transfer is a lot higher, but I haven't used it ever.
It has about the same data rate as Ethernet. It can go to about 100 megabit per second. However, EtherCAT uses completely different protocol. It analyzes and it receives data on the fly. So once it receives a string of data, it starts to analyze it instead of waiting for the whole package to come in. And also, EtherCAT slaves can be daisy chained. So one master can talk to multiple EtherCAT slaves. So if you have multiple modules on your system or robot, it's like Canvas. It's the same idea as Canvas. You can daisy chain Canvas, and you can also daisy chain EtherCAT.
One more thing to learn.
One of the things that we found I'm down in New Zealand, but we decided to go with CAN bus because the engine that we got, which was a Cummins, is CAN bus and it's J1939. But what we found was when we tried to marry all the hydraulics, etc., and the control systems on the tractor, what we found is that everybody was using CAN, and you go and buy something that says CAN, but they don't tell you it's CAN Open or CAN Bus 2.0 or anything like that. So you've got to try to mix all those different cans together. So you've got to have converters in there to go from 1939 to CAN Open just to get all the messages through. It's taken our software guy quite a long time to get his head around that. And I'm not sure whether he has yet, to be honest. So it's sort of say, everybody says, oh, it's on CAN bus and that's all good, but what type of CAN bus is equally as important? It's kind of awkward.
That's a good point. looks like we're running up on the end of time here. Is there any other comments or for tonight? Walter, thanks for joining us. I'd love to hear about your robot. If you can make it, we have a meeting every Tuesday night next week, same time, same place.
Yeah, I'll try to for sure because it's really interesting. We're not using ROS as the actual language, if you like, but it's the stuff that Jeff's doing on the dual antenna GPS is something that we're trying to do at the moment. We have had magnetometers on there, and they just don't seem to cut the mustard. They seem to vary too much, and the heading is such a critical part of the overall project that we really need a solution. And so hopefully, I think on Friday, it's Wednesday down in New Zealand, but on Friday we'll be out in the field, hopefully trying the dual antenna GPS with the F9Ps on there. So that'll be I'll either be smiling or I'll be crying, one or the other.
Yep. Great.
Well, good luck. On the F9P note, I got an email that's free shipping to US and Canada until the 4th of July, and orders over $200.
All right.
Sounds like you're not in Canada though.
You're going to go with the dual GPS for heading?
I didn't catch that. All of that.
Are you using the F9P for heading, or?
I don't have one, but I'm considering ordering one with this free shipping and whatnot.
Well, we started out with the the
M8P.
Yeah, I think it was, yeah, and that was only L1. It was really quite good. We thought it was really good for just having L1, but we tried the F9Ps a little while ago, just as the base rover setup, and they're spot on. I was really impressed with them. I thought they were really good.
It's good to know. Thank you.
Yeah. Howard, thanks for presenting tonight. Really appreciate all your work there and helping the community.
You're welcome.
You guys have a great week, and we'll see you online. See you next week.
You too. Thank you.
Bye-bye.
Yeah.
Goodbye. See you guys.
Okay, goodbye.
Oh.